Welcome back, everybody. In this video, we'll be doing just a couple more examples from section 8.1 and then getting started on section 8.2. So in this first couple of examples, we'll do 25 and 27 here, we're to assume a significance level of 0.05 for alpha. And then in part A, we'll state a conclusion about the null hypothesis. And then without using technical terms, state a final conclusion that addresses the original claim. So the original claim here for 25 is that the percentage of blue M&Ms is greater than 5%. The hypothesis test results in a p-value of 0.0010. So let's think about how those hypotheses had to go. So the claim was that the percent was greater than 0.05. So that's a proportion. P is bigger than 0.05. The null hypothesis would have been that it's equal to 0.05. And then our p-value ended up being 0.0010. The p, notice that this is a different p. It's capital P for probability instead of P for proportion. So sorry about that. Our 0.0010 is less than the alpha we were given. We were given an alpha of 0.05, right? That's less than 0.05. And so we'll reject the null hypothesis. Okay, that would be the answer to part A, is that we're going to reject the null hypothesis. And then what does that mean? Well, if we're rejecting the H0, then that means that there's sufficient evidence to support the claim. So we could just write there is sufficient evidence to support the claim. Okay. 27. Original claim is that women have heights with a mean equal to 160 centimeters. So the claim is that the mean is equal to 160 centimeters. The alternative then is not equal to, right? So we'll go with not equal to. Okay, so then the p-value we ended up getting is 0.0614, which is bigger than 0.05. So we will fail to reject our H0. That would be the answer to part A. And then for part B, if we're failing to reject the H0, then the claim was that the mean is equal to 160 centimeters. So if there's insufficient evidence, so we could say that there's insufficient evidence to refute the claim that the mean is equal to let's say mean height is equal to 160 centimeters. All right, so just wanted to do an example of finishing the hypothesis test. Okay, one more example and then we're on to 8.2. All right, so here it says a medical school claims that more than 28% of its students plan to go into general practice. It's found that among a random sample of 130 students, 32% go into practice. We're to find the p-value for this school's claim. So this, we may as well go through some steps for this. So let's go ahead and do the hypotheses. The claim is that more than 28% plan to go into general practice. The null hypothesis is that it'll be equal to 28%. And then for the p-value is derived from the test statistic. And this one is about a proportion. And so it will be p hat minus p divided by the square root of pq over n. So the p hat comes from our sample, and that says that out of the 130 students, 32% plan to go into practice. The hypothesized value is 28%. And so filling out the details, it's starting to look like that. So let's see what we get for our Z. That looks like 1.02. Okay, so notice that that's not, of course, our Z value. That is going to be our test statistic, really. So our test was right-tailed. We had a critical value of 1.02. So we're using a Z table. So we'll go to our Z table, 1.02.8461 is our area to the left. So 1 minus 0.8461 is 0.1539. So our multiple choice here would have turned out to be D. All right, so that takes care of our couple of examples. We're ready to start doing section 8.2, which is basically about testing claims involving proportions. And we actually just did an example of that. So that's good. So the fine print from our book, we're going to need N, which is our sample size or number of trials. The P hat will be X over N. The Q will be the population proportion. That's the one that's in the hypothesis. And then Q will be 1 minus P. Requirements, the sample observations are a simple random sample. The requirements for a binomial distribution are satisfied because basically it's a binomial kind of experiment because everything either is or is not part of the collection that we're interested in. Okay. So you can read through that. Our test statistic, we saw that was P hat minus P over the square root of PQ over N. P values are given by technology. If not available, we can use our Z distribution. All right, so let's try it. So here it says a medical researcher claims that less than 20% of adults in the US are allergic to a medication. In a random sample of 100 adults, 15% say they have such an allergy. We're to test the researcher's claim at an alpha level of 0.01. So first of all, we'll need the hypotheses. So the claim is that less than 20% of adults have this allergy. So the P will be less than 0.20. Our null hypothesis always contains the equality, so P will be equal to 0.20. Okay, so then we're going to do this both ways. You don't have to do this both ways. I like to do this both ways just so that you have the extra example. So this is going to look like it's twice as much work as it really is. Just keep in mind that you just have to do one or the other of these two ways. All right, so either way, I'm going to end up needing the test statistic. This is about a proportion, so let's get that. Z is equal to P hat, that's from the sample, 0.15 minus, go ahead and write the formula, P hat minus P over square root PQ over. So from the sample, 0.15, from the hypothesis, that's 0.20, square root from the hypothesis, 0.20, and then 0.80, and then there were 100 adults. Okay, so let's go ahead and calculate that. Okay, so I'm getting negative 1.25. Okay, so now either way we would have needed that test statistic. So now we want to see how the critical value method will look. So for the critical value method, we start with the alpha. On this one, we're told that the alpha is 0.01. We have a left-tailed test, so the area in the left tail has to be 0.01. Okay, so then we're going to go to our z-table, because our test statistic was z, and we're going to look and see where we'll get an area to the left of 0.01. And so give yourself a minute to look that up. It looks like negative 2.33. Okay. All right, so then we're going to compare our test statistic, which was this negative 1.25. We're going to compare that against the critical value. Negative 1.25. Remember, our distribution is centered at 0. So negative 1.25 is not going to end up in that rejection region. So we'll fail to reject our H0. Okay, so that's how it looks using the critical value method. For the p-value method, we're going to take the test statistic that we just calculated before, of negative 1.25, and we'll look that up in the z-table and find the corresponding area. So negative 1.25, that is 0.1056. Okay, so that is going to be our p-value, 0.1056, and 0.1056 is way bigger than our 0.01, which was our alpha. And so based on that, again, we'll fail to reject the H0. So the conclusion there, of course, is going to be the same. And so we just have to put that fail to reject in regular language. So the claim was that it's less. So that was the alternative. Okay, so we didn't have enough evidence to reject the H0. And so that means that we're not able to support the H1. So there's insufficient evidence to support the claim. Okay. All right, so then we want to make sure we know what it is that we're doing. So the claim was that it's less than 20%. So then we have a sample of 15%. And so on the face of it, it says, okay, well, it's 15%, which is less than 20, and that's what the researcher said. But what it is that we're doing here is that the 15% could be just variation due to chance, right? It's not lower than 20% by enough to be compelling. Basically, we can attribute that difference from 20%, we can attribute that to chance, or at least at an alpha level of 0.0. Okay, another example. All right, so this one I've already done part of it for us to save a little bit of time. So here it says the Pew Research Center claims that more than 55% of adults, U.S. adults, regularly watch a network news broadcast. You decide to test this claim and ask a random sample of 425 adults in the U.S. whether they regularly watch a news broadcast. Out of those adults, 255 respond yes. At an alpha of 0.05, is there enough evidence to support the claim? So the claim is that more than 55% watch. So that means that P will be greater than 0.55. And our null hypothesis is that it's equal to 0.55. Okay, so then the test statistic, I'd gone ahead and calculated that for you. So one thing that is different on this one versus some of the others is that our p-hat in this one is not given to us already as a percentage. So we've sampled 425 adults, and it said 255 responded yes, right? And then that 255 out of 425 is where that 0.6 is coming from in our calculation of Z. Okay, so there is that. The 0.55 down below comes from our hypothesis, as we had seen before. So this one saves us a little time because we already have that critical value, or that test statistic calculated. So critical value method, we'll start with our alpha. This is a right-tailed test. Our alpha is 0.05. Okay. So if we have an area of 0.05 in our right tail, then that means the 0.95 is to the left. And so that again will be a critical value of 1.645. Our test statistic is 2.07, which is in the rejection region. So we will reject H0. Okay. P-value method. Still a right-tailed test. Our test statistic was 2.07. So we're going to find out the probability for that. The area to the left is 0.9808. And we wanted the right tail those, so we'll subtract from 1. And that's 0.0192. Okay, and that's less than 0.05, right, which was our alpha. Since that probability is less than our alpha, we're going to reject the null hypothesis. Okay, so the claim was the alternative, right? More than 55%. So you may want to write the claim next to whichever hypothesis corresponds to the claim. So we were able to reject the null hypothesis, which means that there is enough evidence to support the claim. All right, so we've written out our conclusion as a plain English sentence. There's sufficient evidence to support the research center's claim. All right. Okay, next example. So make sure that you're trying each of these, by the way, before I go through them. In a 3M privacy filters poll, 806 adults were asked to identify their favorite seat when they fly, and 492 chose a window seat. So I can tell you now that that's will be 492 out of 806, or 0.6104. Okay, we're to use a 0.01 significance level, that's our alpha, to test the claim that the majority of adults prefer window seats when they fly. So on this one, it doesn't explicitly state a percentage, but you have to think of what constitutes a majority. The majority would be most or more than half, right? So majority of adults basically means that the proportion is bigger than 0.50. And so the null hypothesis that it's equal to 0.50. So then test statistic next. So we'll have p hat minus p square root pq over n. Okay, the p hat worked out to be 0.6104. The claimed is 0.50, or when it's in the hypothesis is 0.50. Okay, so then our p from the hypothesis is 0.5, so our Q is the same. Our sample size, be careful here, I almost wrote 492, is 806. That's the size of our sample. All right, so that's Let me calculate. All right, so I had to double check my calculations there because the Z value came out really large at 6.26. So on this one, for the critical value method, it was a right-tailed test. We had an alpha of 0.01. Okay, so if there's 0.01 in the right tail, then that means that there's 0.99 is the area to the left, and that's going to be 2.33. Check that. Yeah, 2.33. All right, so we don't have to really work too hard at that because it's clear that our Z value is way higher than that, right? And so we're going to definitely reject our H0. Okay, and then the p-value method here, this one is going to be like a little weird because your Z table is not even going to go up to 6.26. So the one that I'm using today only goes up to 3.9. Okay, and so it's going to be at least 0.9999 to the left, and so less than 0.0001 to the right, and so that's definitely less than our 0.01. And so again, we're going to reject our null hypothesis. Okay, so then on this one, our claim was the majority of adults. So again, that's going to be the alternative hypothesis. And so you could say there's sufficient evidence to support the claim. All right, so we've written out the conclusion. There's sufficient evidence to support the claim that the majority of adults prefer window seats when they fly. Okay, so we just have two more examples in this section. So let's see. So here it says, according to the Center for Disease Control, the percent of adults 20 years of age and over in the US who are overweight is 69.0%. One city's council wants to know if the proportion of overweight citizens in their city is different from this known national proportion. Okay, so the fact that they're saying they just want to know if it's different, that makes it sound to me like a not equal to, right? So the known proportion is 69%, and so that will be our null hypothesis, is that this city its proportion is also 69%. And so the alternative here, based on the wording, they're saying, okay, is different. So that's just not equal to. So we'll have not equal to 0.69. Okay. And so let's go ahead and get a test statistic next. All right, so then our sample proportion, they found 98 out of 150. So p hat is 98 out of 150. And that's about 0.653. Okay, the one from the hypothesis is 0.69. All right, so that is lower. We'll just see if it's significantly lower. How many were surveyed? 150 adults. Okay, so let's calculate. All right, so I've gone through the calculations. We ended up with a test statistic of negative 0.98. So critical value method first. So on this, it is a two-tailed test. We're told that our alpha is 0.05. Since it's two-tailed, that means that 0.025 will be in each tail. Okay, so then if 0.025 is in each tail, then that means that to the left of the critical value on the right, we should have 0.975 for our area. And so our two critical values are going to be 1.96 and negative 1.96. All right, so then our test statistic was negative 0.98, which is negative, sure, yeah, but it's not less than negative 1.96. And so we're going to fail to reject our H0. Okay, and then we also want the p-value method. So then for the p-value method, our test statistic was negative 0.98. So then area to the left of negative 0.98 is 0.1635. Okay. This was a two-tailed test though, right? And so our p-value will be twice that much because we need to account for both sides. So 2 times 0.1635 is going to be 0.3270. Okay, and that's definitely bigger than our alpha of 0.05. And so as before, we will fail to reject our H0. All right, and then in the context of the problem, our claim, they want to know if the proportion is different, right? So there was not sufficient evidence for us to reject the null hypothesis. So that means that there's not enough evidence to support the claim that the proportion is different, okay? So we can go ahead and write that. All right, so we've written that up as a sentence. There's insufficient evidence to support a claim that the proportion of overweight adults is different from that of the US as a whole. All right, so here's our last example. So here it says, in a Harris poll of 514 human resource professionals, 45.9% said that body piercings and tattoos were big grooming red flags. Use a 0.01 significance level to test the claim that half of all, let's go ahead and make that less than half of all human resource professionals say that body piercings are grooming red flags. So the claim is that less than half. So the proportion is less than 0.5. And so our null hypothesis is that it's equal to 0.5. Okay, so then test statistic. So our sample statistic is 0.459. From the hypothesis, it's 0.50. You're probably getting the hang of this by now, which is good. Our N is 514. So once again, let's calculate that. All right, so I calculated a test statistic of negative 1.86. So then critical value method, our test is left-tailed. Our alpha is 0.01. And so our critical value is going to be negative 2.33. Yep. Okay, and then our test statistic was negative 1.86, which doesn't fall in the rejection region, so we would fail to reject the H0. All right, p-value method. For the p-value method, we use the test statistic, and from there locate the probability. And then we'll have to compare that probability against our alpha. So negative 1.86 is 0.0314. Okay, so 0.0314 is bigger than 0.01. Okay, so again, we're going to fail to reject our H0. Okay. All right, so again, notice that we came to the same conclusion. And then in this, the claim was less than half. That was the alternative. We saw that there was insufficient evidence for us to reject H0. So there's not enough evidence to support the claim. If we can't, see, H0 and H1 are mutually exclusive. So if we can't conclude that H0 is false, or that we can't reject H0, then that means that we can't support H1. So that means that there's insufficient evidence to support the claim. All right, so that takes care of that. What I would like to do next is use this example to see how we would do hypothesis testing in StatCrunch. So let me get that set up. All right, so here we are in StatCrunch. So to do the hypothesis test, we'll go into Stat, and then we're doing something with proportion. You want to be careful here because it says Z-stats. We're actually working on proportions though. So go down to proportions and then one sample. And then we have the summary information. We don't have the raw 514 results. So with summary. And then in this, in the problem about the human resource professionals, we were given the percentage, which was 45.9%. So we need to actually turn that into a number of successes. So 45.9% is about 236. So we'll say 236 out of the 514 observations. And this is the same basic thing that we would have used to get a confidence interval. As you can see, the second radio button here is for confidence interval. This time though, we are doing the hypothesis test. And we've got our null hypothesis in here that it is equal to 0.5. That's the default they gave. And then our alternative, let's just use the drop down here to switch that to be less than. Okay, so we'll do that. And then the last thing we need to do is hit compute for that. And then for this, we get our calculated Z statistic, which is negative 1.85, and our p-value, which worked out to be about 0.032. So that slightly differs from what I got as far as a p-value, and that's because of the fact that we'd had 45.9% for a sample proportion, and I turned that into a raw count of 236. Okay, so there's a little bit of an approximation there. You'll notice that using the technology, StatCrunch and other software typically lean towards producing p-values. They really don't do the critical value approach. The critical value approach is one that was taken more prior to there being so much technology tools available for our use. All right, that takes us to the end of section 8.2, but we've got a lot done. In the next sections, we'll be doing the same basic thing here where we did for proportion. We'll do just a bunch of hypothesis tests for means, and it's going to work about the same way. We'll have to decide if we're going to use a Z table or a T table, depending on whether or not we know sigma. And then in the section after that, we'll be doing it all again for some tests involving standard deviation or variance. And for that, we will be using the chi-squared distribution. Okay, so that takes care of that. As always, let me know if you have any questions, and have a great day.